Well, welcome back, guys, to preparing for the exam, I guess. And today I'm going to complete my discussion of sequences and series, and I'm going to do another couple of examples, kind of short examples, and I'll give you a nice summary of what I think is important at the end of this video. Okay, so we're going to start with a small example. We're given a series over here, and we're asked to compute the sum of the series up to the sixth term. Okay, I'm not going to write in red all the time, so let me just change that. Okay, well, the first question then that arrives is, well, you should ask yourself, is it a arithmetic series, or might it be geometric? Okay, super important. What happens here is you need to test this then. So for arithmetic, we know that the distance here should be the same, right? These two distances, d1 equals d1. Well, already by inspection, you can see that this is not going to be true. So for d1, I'm going to have 50 minus 25. That's going to be 25. And then for the other d1, we're going to have 100 minus 50. Well, this is 50. And clearly we can see that this is not the case. Okay, so we rule out this. For geometric, well, we need to calculate the ratio between the terms. Okay. So a ratio here, R1 and R2. Well, R1 equals 50 divided by 25. That's 2. And R2 equals, well, 100 divided by 50. That's 2. Okay. Written both really badly. But the point is, R1 equals R2. And so we know this is a geometric series. Okay. This now allows us to implement some equations, because for a geometric series, well, I can't write something out yet, because I first need to realize that to write this formula over here, the value of this r here, super important. Okay, so in this case, for this example, r is larger than 1. And so t1 equals a multiplied by r to the power of n minus 1 over r minus 1. Okay. And so I know a, well, a is just the first number in the series, that's 25. R I've calculated to be 2, and they've asked as 60, not 66, t to the 6, let me just write that correctly, minus 1, and r is 2 minus 1, and the sum here, well, you can go and compute that. I hope this is clear, but the only tricky part here is to determine whether it's arithmetic or geometric. And then it's a case of going to compute r and applying the formula, relevant formula for r is greater than 1. And this guy over here. And that'll be given in the question sheet in any case, right? Okay. Next example. I'm giving a series over here. I'm giving the solution, or the sum, of n number of terms as a clue. And they want us to determine, well, how many terms did I sum together in this series to get 728. Okay, so first step over here. Again, I'm stuck because I don't know which generic formula to use, because I haven't computed r yet. So the first step will be to look, well, is it arithmetic? 6 minus 2 equals 4. And that, d2, was 18 minus 6. Well, that's 12. So it's not arithmetic because D1 is definitely not equal to D2. Okay, so I know it has to be geometric, and therefore I have to calculate these ratios now. R1 equals 6 divided by 2, that's 3. Just to test it, R2 equals 18 divided by 6, that's 3. Okay, so R is larger than 1. I get to apply this formula, therefore, that we just seen. I'll just get it over here. And it's right here. This is the sum. Okay. And I have a r to the power of n minus 1 divided by r minus 1. Okay. I know this is 728. I know the first term in the series is 2. Therefore, a equals 2. Write that there. I know the value of r is 3. And this n is unknown, right? This n is what I have to go and compute. So that is 3 minus 1. Okay, this is 2 divided by 2, cancels out. I take that minus 1 over, so I have 3 to the power of n equals 729. Okay, how do I solve this then? That's an exponent. Well, I can log on both sides, right? And then using the exponent laws, I can get n log 3 equals log 729. And if you go and compute that, you get n equals 6. That's the answer. Cool. Easy. You've just got to compute again whether it's arithmetic, like here, or whether it's geometric. You know that it's geometric because these two r values are the same. Then it's a question of knowing that r is larger than 1, choosing the correct formula to use, right? Substituting the a, because you know it's the first term in the series. And then applying the log law over here to get this n away from exponent into the equation. Okay? So, example 2 done. Example 3. Well, let me get a different color here. We have a sequence, and we're asked to write down a recursive formula for the sequence. Okay. Important always to just quickly have a quick glance at the sequence. What's happening here? Well, we can see, hey, there's a difference. 4. There's a difference of 4. Okay, so we seem to have constant differences, right? 4, 4. So it's a arithmetic sequence. Okay, what do we know about that then? We've diagnosed it correctly and we know which formula to use. But they wanted in a recursive formula, so we know that. We're going to write it out. First, specifically, term 2 equals term 1 plus d. So, I'm going to write this generically now. Let's just get this right. Term n equals term n minus 1 plus d. Okay, and I've just computed here very roughly that d is 4. So, minus 1 plus 4 Tn. That's your solution to the recursive formula. 3 marks, super easy. Okay, the other formula is what I was talking about earlier, that we know what the generic formula for an arithmetic sequence is, right? We know that it looks like this. And again, this is given in your question sheet, at the back of your question sheet. There we go. We know A, and we know D, so we could just go and write that. Well, we know Tn equals 2 plus n minus 1 times 4. You can simplify it a bit if you want to. 4n minus 2. That's it. 2 marks. Done. As a final example, look at this example. They're giving us all the information we need. We're given the clue. We don't have to diagnose the sequence, but we know that it's an arithmetic sequence. Okay. They're also telling us the second term is equal to 8. And this is our first piece of information. And they're also telling us the fifth term is equal to 10. That's our second piece of information. Okay. First question then is determine the common difference. So they want D. But notice we're not given a sequence. We're given just little clues over here, right? But we're given 2 pieces of information, 1 and 2. We need D. That's what they want, 3 marks. So what are we going to do? Well, the clue lies in this. We know that there's a formula for this, right? Let us write this down. Tn equals A plus n minus 1 times D. This D. We have, therefore, in this equation, 2 unknowns, but we're also given 2 pieces of information. So we're going to solve this using simultaneous equations. Okay, I'm going to help you set them up. The first one is the value of this term is 8. A, I don't know. Okay, this is the second term. So n is 2, and the value of D, I don't know. I'm going to simplify this a bit. Let me see. 8 or 8 equals A plus D. That's equation 1. Okay, second bit of information. Well, the fifth term is 10. So 10 equals A plus the fifth term, because now n equals 5 times D. Okay, so simplifying this a bit, 10 equals A plus 4D. That's equation 2. Okay, I'm going to rewrite now equation 1. Okay, I'm going to say A equals 8 minus D. I'm just taking the D over to the other side. Okay, and this is equation 3. Okay, and then I'm going to do a 3 in 2 situation. Okay, so work with me. We're going to have 10 equals 8 minus D plus 4D. Okay, and if we solve this, then blah de blah de blah, get D equals 2 over 3. That's the answer for 3 marks. Now remember this equation because we're going to use it again. Because we haven't solved A. So A equals 8 minus D, and D equals 2 over 3. Okay? We have to now write down, just change the color, this blue is irritating the crap out of me. We have to write down the sum of the first 50 terms of the sequence. They want us to use sigma notation. Okay? So, sum of the first 50 terms equals sigma notation. I'm going to use this n still that we've been using all the time, and we know we have to choose, calculate from the first term to the 50th term. Okay? And we're just gonna fill in numbers. So we have A, which is we haven't calculated yet. So A equals 8 minus a third. Well, that is 7 2/3. Sorry, jumping ahead. 7 1/3. So we have 7 1/3 over here, plus n minus 1 times 2/3. Okay. Sigma notation. 2 marks. Last piece of the puzzle. Well, we got to calculate this first 50 terms. Not just now the sigma notation, but actually the number. Okay. Equals this formula. And write it first generically. Do it a little bit neat also, so that I help you out. Keep structure to the whole thing is always super important. Okay. And this formula is also given in your question sheet at the back. So there we go. We have all the pieces of information because we know they want the first 50 terms. That's 50 divided by 2. It's 2 times 7 1/3. That's plus, well, let me write this out. 50 minus 1 times d, that was 2/3. And I think the answer is 3,550/3. Go double check me. Okay, and important to know that you have to use this formula for the sum of an arithmetic sequence. Okay, so to summarize, I'll just like to draw your attention to this slide over here, which I thought was nice. Okay, so we have sequences and we have series, right? Then we differentiate between a arithmetic sequence, a quadratic one, and a geometric one. Okay, so let's take them step by step. The arithmetic sequence, which we saw now here in the last example, you calculate d, and crucially these d's are equal, right? And this is the formula you use to calculate the d. Okay, general formula for this sequence you've also seen before, and I said previously also, this is given. And if you plot the numbers in this sequence, it's always going to give you a straight line. Okay, then for a quadratic sequence, well, we saw that in the first example I did in the video series. And I've also looked at it a bit, and it seems that there's 2 or 3 other exam papers where they ask a quadratic sequence, so they quite like this. We know that this is its general formula. Okay, it's got a common second difference. Got to go and look what that means. But importantly, if we draw the numbers in this series, always get a parabola. Okay, and a geometric sequence we saw, well, with a geometric sequence we have to, this depends on the ratio between consecutive terms. Okay, and this is its general formula. And now the elements in this sequence lies on an exponential curve. Okay, so 3 important equations to remember. And on the one, you calculate the difference. And the other one, you have a common difference between common second difference. Go and have a look at examples that have these kinds of sequences. And in the third one, you have ratios, okay? Cool. And then for series, well, we also differentiate between arithmetic series and geometric series. Skipping ahead to the second part here, we had a look at this in one of our examples in this video for the case where r was larger than 1. And then we also now, in this last part, use this to calculate the sum of the first 50 terms. So we also had a look at this a bit. Be aware of these differences and how to implement them